By now you should have read through all of the terms on the notes page. If you have not, please pause the video now. You should be familiar with most of the terms on the handout. A few that you might not be familiar with, I'm going to go over first. The first terms are positive and negative angles. I've got an angle shown here, and whether it is positive or negative is determined by the direction in which it's measured. If I measure the angle in this direction, it's a positive angle. So counterclockwise is positive. If I measure clockwise, it's a negative angle. The angle doesn't actually change in any way, but the measure we give it is determined by the direction in which it's measured. As soon as we place an angle on a coordinate plane, it's now called standard position. What we're looking for is for the vertex of the angle to be located at the origin. The initial side of the angle, meaning the side that we're going to start our measurement from, is aligned along the positive x-axis. The terminal side of the angle can be located anywhere else. So angle A here is a quadrant 1 angle. That means that it's between 0 and 90 degrees. Angle B, again, vertex is at the origin. Initial side is along the positive x-axis. We're going to measure counterclockwise, so it's a positive value. B is going to be in between 90 and 180 degrees. As you can see, quadrant 3 and quadrant 4 angles also exist. When we talk about quadrantal angles, those are the angles that are located on both axes. So the initial side is still along the positive x. A quadrantal angle might be a 90-degree angle here. It may be a 180-degree angle if you start with the initial side and the terminal side is on the negative x-axis. You could have an angle that's 270 degrees, like this. Any angles aligned along the axes are quadrantal angles regardless of how many rotations they go through. That leads us to coterminal angles. Coterminal angles look the same. The reason they're coterminal is because the terminal side of the angle might rotate through more than 360 degrees. If you notice the 60-degree angle here, the initial side is along the x-axis, the terminal side is in quadrant 1, it rotated up 60 degrees. We can create the same angle by rotating through 360 and then an additional 60. If we do that, we get an angle that's 420 degrees. Similarly, we can actually move backwards. If we move in the clockwise direction, we know our angle is going to be a negative value. So this we can start at the initial side and move backwards. If we go 360 degrees, it's too much. So I would take my 60, subtract off 360. That will give me an angle that's negative 300 degrees. Taking a look at this next one, we've rotated through quite a few. There's 360 once, and 360 twice, then we move through 110. So I can say 360 times 2 plus 110. These are coterminal angles. So we'll take a look at some examples. To begin with, we're finding a complement of an angle. Remember that complement means that they add up to 90 degrees. So if I'm looking for a complement, what I'm going to do is take 90 degrees minus 55.62 degrees. That gives us 34.38 degrees. This is the complement. I can also find the supplement. Supplement means that the two angles add up to 180 degrees. So here I simply take 180 and subtract out my angle. And this gives me 124.38 degrees. Usually when we look at supplements and complements, we're given something more like this. I know that this is a right angle because of the little right angle symbol. So what I need to do is I know that 2r plus 3r have to be equal to 90 degrees. So I solve this algebraically. So I know that r is equal to 18. But I'm also asked to find the value of the angle. So the smaller side is 2r, and the larger side is 54. And you can always check this by making sure that they add up to equal 90 degrees. We can look at supplements the same way. The angle shown is a straight angle that has been split, so I know that these have to be supplementary. So 7t and 2t must equal 180 degrees. So t is 20. When I solve for the two angles, and again I can check to make sure that they are in fact supplementary or that they add up to 180 degrees. The next problems use degrees and minutes. You have to remember that there are 60 minutes in 1 degree. So when I'm looking at these, what I'm going to do is set it up like one of the old-fashioned addition problems. I'll make this 63 degrees, 52 minutes. When I add up my minutes, I get 87 minutes. When I add up my degrees, so I have 91 degrees, 87 minutes. Okay, well, I don't really use 87 minutes. So what I'm going to do is take out 60 minutes, because 60 minutes is 1 degree. When I do that, I end up with 27 minutes. So this 60 minutes actually gets added into my degrees. So I have 92 degrees, 27 minutes. When you subtract, it's like when you were borrowing. So we take that 180 and we now make it 179 and 60 minutes. So I can still subtract. I have 31 minutes, 62 degrees. Sometimes we need to convert our degrees, minutes, and seconds to decimals, and sometimes we have to convert back. So for the first one, what we'll do is we'll start with our 105 degrees. We know that a minute is a 60th of a degree, so 20 minutes is 20 60ths, and we'll need to add those together. A second is a 60th of a minute, which makes it a 3600th of a degree. So here we've got 32 3600ths. Now all we have to do is enter this into our calculators to get our decimal degrees. to go from decimals back to degree minute seconds, first we separate out our degrees and we look at the decimal portion. You're going to multiply that by 60 to get your minutes. And we get 15.78. So I know I've got 85 degrees. I've got 15 minutes. Now I have to take this portion of it, the 0.78, multiply it by 60 to get my seconds. And you get 46.8 seconds. And you can leave your answer just like that. Next, we're asked to find angles of least positive measure coterminal with each angle. What that means is I am looking for an angle from 0 to 360 degrees. So I want to be going in the counterclockwise positive direction and also only rotating through the circle at most one time. So on this first one, I'm going to start subtracting 360 degrees. Which gives me 746. Okay, well that's still not least positive measure, so I'm going to subtract off 360 again to get 386. And so I'll have to do this a third time to get 26 degrees. Least positive measure. On the next one, because I'm moving backwards, I actually need to start adding 360 degrees to get that positive value. That will get me a positive 210 degrees. On the last one, same thing. I have to start adding 360 degrees. This gives me negative 243. That's not least positive, so I have to do it again. Add 360. This gives me a positive 117. What you're doing is you are adding or subtracting multiples of 360. Our last problem is a word problem. A wheel is going to make 270 revolutions per minute. Through how many degrees will a point on the edge move in 5 seconds? For something like this, I'm going to do what you learned in chemistry class, the railroad. So what I do is I say 270 revolutions occur in 1 minute. I need to convert revolutions to degrees. So I know there's 360 degrees in 1 revolution. And then I need to convert minutes to seconds. So I know in 1 minute there are 60 seconds. So that's my first step. If I'm multiplying this, if I look at these as fractions that are multiplied, anything numerator and denominator cancel. And this leaves me with degrees per second. And it shows me right here I'm looking at degrees in seconds. So now all I have to do is multiply across, divide by 60. When I do that, I get 1,620 degrees in a second. But we are asked how many degrees in 5 seconds, so we need to multiply this times 5, and we get 8,100 degrees in 5 seconds. Because this is a word problem, we'll write this as a complete sentence. And that's it.